Okay, when we left off yesterday in lesson 7.5, we were just working on kind of finishing off the front page, solving exponential equations. The top of the page, we were using that gold paper, right? We were making the bases match. The bottom of the page, the bases weren't matching, so we were having to do what?
Logarithm.
Take the logarithm of both sides. Okay, so when we left off yesterday, we had a couple minutes left, and I asked you to attempt E on your own. Some of you got through it, succeeded. Some of you got through it. Answer wasn't quite right, and I'm not sure everyone attempted it. But we're going to look at E, and then we'll probably move on to the back side. Okay, so I looked at the homework this morning. We don't need to worry about F right now. So that adds another extra level, and I'm not going to worry about those right now. So, on E, did you try and think gold paper first?
No.
Probably not, because it was in the section, right? But can 5 and 9 be rewritten with the same base? No, it cannot. And so, what did you have to do? Take the log of both sides. So, log of 5 raised to the x minus 3 equals log of 9. Okay? Once you take the log of both sides, what's our next plan? Cyrus?
Use the power property and put x minus 3 in front.
Okay, we want that power property. We're going to move the power out front, which in this case, my power is x minus 3. Because my power is x minus 3, it's two terms. I'm going to put it in parentheses. So x minus 3 times log of 5 equals log of 9. And again, if you recall from yesterday, this was the little more difficult type, right? So what do I do now? Okay. The direction we went with this is, since it's x minus 3 times log 5, we opted to divide by log 5. If we divide the left, divide the right. What happens with those log 5s?
They cancel out.
Logs cancel. I have x minus 3. And this is where I kind of gave you a choice, right? You can go ahead and put this in the calculator right now and write down decimal if you want. Or what I tend to do is I just leave it like this for the moment, and I'll get decimals later. So x minus 3 is log 9 divided by log 5. How do I solve for x? It's x minus 3. We're going to add 3. So x equals okay. And this comes down to trying to think, could you do this in your calculator all at once? Depends how your calculator works and how you enter it. Okay? Honestly, in my opinion, what's easier is to just go ahead and do the log 9 divided by log 5. Enter log 9 in parentheses, divide by log 5 in parentheses. I would say, just to be safe, hit equals there. And then you can, while it's still on your calculator, add 3. Now, if you have played around with your calculator and you know what you can and can't do, that's good. If you know you can go ahead and put it all in at once, that's fine. I just don't want you to get a test situation where you have all the right work written down, but then you have miss a point because your calculator answer doesn't come out right. So know how to use your calculator. What answer did you write down here for 4 decimal places?
4.3.
Okay, good. 4.3652. Okay. Good review from yesterday? Can I review what we learned yesterday? Remember, if you can make the bases the same, we did that first. If not, we took the log of both sides. Okay, so flip to the back. Let's look at this word problem here. It's a word problem. We've got to attack it. The equation t of x equals 1,200,000 times 9300ths to the power of x is used to model a lumber company that has 1,200,000 trees and plans to harvest 7% of the trees each year, where x is in years. How many years will it take to harvest half of the trees? Now, as always, what's good news here? They gave us an equation, right? So we know we're going to be using this equation here. Well, trees take a while to replenish, though. I mean, it's not, and especially the type the lumber company are taking. The lumber company's not taking the young trees. They're taking the older trees, the bigger trees. Okay, in preparation, all I did was write down my formula. I feel like I wrote it kind of small, sorry. You have it there in front of you, though. Now, notice what's already in that formula. They already have the 1,200,000, don't they? Which was the initial population of trees. Do you remember exponential equations? That front number was the initial value when we did these last week. Then it talks about harvesting 7% of the trees. Do you see how the 7% is already in the formula? Yeah, because if you're harvesting 7% of the trees, you start with 100% of trees, you take away 7%, what's left? 93% of the trees, right? So this is like an exponential decay problem. Now, the question is, how many years, and where is years? So this means we're trying to solve for x. How many years will it take to harvest half of the trees? What do we mean half of the trees? Okay, 50%, but half the trees is 600,000. It didn't tell us that number there. Okay, you have to do the reading and figuring out, but you need to realize that half of the trees, half of 1,200,000 is 600,000. So this is the value that we're going to put in for t of x. Okay, because we want to know in how many years will it take to harvest half. So set up your equation. In place of t of x, I'm going to put 600,000 equals 1,200,000 times 0.93 to the power of x. I feel like I need to zoom in. I feel like I'm writing really small. Not on purpose. I just feel like it looks small. Okay, guys. Thoughts on how to solve this? Yeah, don't let the numbers scare you. We're not going to just put random numbers in this time. We have solving methods. Think about the solving methods we used on the front of this paper. Okay? Kendra? Okay, so what you guys need to think about here. On the front side, it was, okay, can I use the gold paper to get my bases the same, right? And that was, if I can't, I'm going to take the log of both sides. But before you can ask yourself these questions, and this is how this problem's a little bit different, that base has to be by itself. And what do you notice over here? It's not just 0.93 to the power of x, it is 1,200,000 times 0.93 to the power of x. And so with that in mind, we need to, before we start either getting the bases the same or taking the log of both sides, we need to get this exponent and whatever it's on by itself. So how do you get 0.93 raised to the power of x by itself? Well, if it's being multiplied by 1,200,000, we're going to divide. Now, if I divide the right side by 1,200,000, guess what? We're doing the left. You might be able to do this without a calculator if you think logically. 600,000 was what portion of 1,200,000? It was 1/2. So guess what? When you do 600,000 divided by 1,200,000 on your calculator, what's it going to give you? 1/2 or 0.5. So this equation becomes 0.5 or 1/2 equals 0.93 to the power of x. Suddenly it looks less scary. Good point. Huh? No, because it still has decimals. Is that the problem? Okay, well, yesterday I said, can I get the bases the same? And my bases are decimals. Is this paper going to work for decimals? No. So the second half of the day we learned we can't get the bases the same. We what? Take the log of both sides. So we're going to take the log of 5/10 equals the log of 93/100 to the x. Use your equation solving skills. What's the step I have to take here? Power property says we take the x out of the power and put it out front as a coefficient. So the log of 0.5 equals x times the log of 0.93. If it's x times that log, how do I solve for x? We divide it by log of 0.93. So, my answer requires the use of a calculator. It's going to be whatever you get when you plug in log of 0.5 divided by log of 0.93. Practice with your calculator as always. Helps if my calculator's on. Log of 0.5 divided by log of 0.93. Did your answer match my answer? I have two decimal places written down. So I have written down that this is approximately 9.55 years. So it's going to take, what, just a little over 9.5 years to get rid of 600,000 trees at the rate they're going. That's a long time. That's a lot of trees. Okay. Because I want to make sure we have plenty of time for the bottom section, I'm not actually going to work the next one. But look and see what would change. It says, after how many years will you have harvested half of the trees if you harvest 5% instead of 7%? what would change? Think about where I pointed out the 7% effects, and what would change then? Cyrus?
So 0.93 would be 0.95.
Yeah.
Thank you.
Yeah, it would become 95% instead of the 93% in the parentheses. So you would set up the same exact equation, but instead of taking out 7%, 100 minus 7 is 93, you would take off 5%. 100 minus 5% would be 0.95%. If you worked this and got an answer, you would get that answer of 13.51 years is what I've written down. Did I answer your question in there, Allie? Okay. Your hand went down before I got a chance to get to you, so. Okay. Okay then, example 4. Last type of problem we have in this lesson. The front side was all about solving exponential equations. It was always an exponent, x in the base, right? Every single problem. Well now, if you look in this back section, we're probably going to do about 4 out of 6 of these. I'm going to pick and choose the ones that will be the best help of us. Notice these have logs in them, right? So as we look at A, log of 4x minus 3 equals 2. What is the solution? So dig deep in those brains and think about how we have dealt with log expressions previously in the last couple of days. Because right now, x is inside that log, isn't it? So my question to you is, how do I rewrite this so it's no longer a log equation? How do I get it out of logarithm form? What? Left, right, middle? Do you guys remember left, right, middle? This is the time to use it. Let me write this off to the side here as your reminder, so you have the visual reminder. Left, right, middle. Okay, before we do left, right, middle, I'm off the side of the screen altogether, aren't I? Okay, is that better? Before I do left, right, middle, what must we acknowledge? Base 10, right? It's not written in, which is fine, but it is there. And that's important. So, log base 10 of 4x minus 3 equals 2. Left, right, middle. What's the left? 10. Raise the number on the right. What's my right? 2 equals the middle value, which is whatever is inside your log. So I just wrote the equation, 10 to the power of 2 equals 4x minus 3. This might be one of the easiest equations you've solved in here in a long time. If you can get past the fact that there's 10 squared in there. What is 10 squared? 100. So this equation, if you want to flip-flop the sides, you can. This equation is really just 4x minus 3 equals 100. Okay, go back to your middle school days. If it's 4x minus 3, what do I do? The opposite of subtracting 3 is to add 3. 4x equals 103. How do I solve for x? If it's 4 times x, we're going to divide by 4. 103 divided by 4. Okay. Calculator says 25.75. 25 3/4. And based on what we're doing in this lesson, I'm fine with decimals. That wasn't bad, was it? We've technically already done something like that. We've already used left, right, middle. That's not brand new. Okay. Let's practice B then, if you would. Log of 3 minus 2x equals negative 1. Again, we are in log form. I first need to probably acknowledge that invisible base 10. Okay, how do I write this out? Left, right, middle. 10 to the negative first equals 3 minus 2x. Okay. Teensy extra difficulty here. But 10 to the negative 1. If we don't go calculator-wise and just use our brains, what does a negative exponent do? To make it positive, it goes to the bottom. So this 10 to the negative 1 is really 1 over 10. Now, some of you already did it on your calculator, right? What's your calculator tell you 10 to the negative 1 is? 0.1, which 0.1 properly said is 1/10. Does it matter if you go decimal or fraction here? I'm going to say it probably doesn't. Okay, I don't see Math Excel requiring a fraction type answer here. I could be wrong, but that's what I would say. So, if we want to rewrite this out, I'll go your way for a change. 0.1 equals 3 minus 2x. I'll be nice. Okay. My job is to solve for 2x, or solve for x, which means solving for 2x. So what do I have to move away first? The 3. It's a positive 3, so to move a positive 3, I'm going to subtract 3. What is 1/10 minus 3? Negative 2.9 equals negative 2x. How do I solve for x? Divide by negative 2. Negative 2.9 divided by negative 2. Positive 1 45/100, 1.45. Okay, we got the basics. Left, right, middle. Until I throw a change at you, right? I'm going to skip C. It's too boring. C is 19.6 if you've already worked it, or if you want to work it. It's a little more boring than what I want. D, E, and F. I think I'm actually going to do E. I know. Normally I go straight to D, but I think I'm probably going to do E and F. I'm trying to get you guys a little bit of work time and trying to pick wisely which problems I do. So let's go to E, if you would. And whether we go to D, E, or F, what's different about all three of these on the bottom row? Did someone say it? Okay, there's more than one log in all of these, right? So in order to use our phrase left, right, middle, we are only allowed to have one log. Okay. No? Okay. Can we take two logs and rewrite them as one log if they're the same base? Yes. If the two logs are being added, you rewrite it as one log where the insides are multiplied. If the two logs are being subtracted, right here, we rewrite it as one log where the inside is divided. So how can I rewrite log of 6 minus log of 3x? Log of 6 over 3x. Still equals negative 2. Okay. Yes?
Do we just know to put the 6 on top because it comes first?
Yes.
Okay.
When you're writing your division, the first one always comes on top.
Okay.
Yep. Okay. Now you guys take back over. I have 1 log equals a number. How do I get out of log form? Left, right, middle. So 10 to the negative 2 equals 6 over 3x. Okay, what are some thoughts you see here? Because there's a couple different ways I could take you here, so that's why I'm... Carter?
Well, 10 to the negative second is 1/100.
Okay. 10 to the negative second is 1/100th. So it's 1 over 10 squared, which is 1 over 100. Now, do you want to go fraction or decimal 1/100th?
I like decimals because they're easier to plug into.
You like decimals? Okay, we can make decimals work. I will make decimals work for you guys. So if that's the case, 0.01 equals 6 over 3x. I see a fraction. Even worse is that the x is in the denominator of the fraction, but that's okay. How do we get rid of a fraction? Allie? Multiply by what? Not 6. The 3x. Multiply by whatever the denominator is. Okay? I know we'd rather just multiply by a number because that seems more normal, and it is. But multiply by whatever your denominator is. Since that's 6 divided by 3x, your best bet is to multiply by 3x. If you multiply one side by 3x, you multiply the other side by 3x. Now, on the left, you guys want to go decimal, so that's fine. 3x times 1/100. Well, what is 3 times 1/100? 3/100. So this is 0.03x equals, you can multiply anything. They don't have to be like terms. You can only add if they have to be like terms to add. On the right, what happens with the 3x's? Yeah, the whole point of multiplying by 3x is it cancels and we're left with 6. And then we just divide. So it looked ugly for a moment there in the middle, but 0.03x equals 6. You are dividing by that 3/100ths. And x becomes 200. If I take 6 pies and I am dividing them into 3/100th pieces. So I'm dividing them in taking each pie, kind of like into 100 slices, but sets of 3, right? It's hard, so a very small piece. Okay? Dividing by decimals is a weird thing, and I think everyone's always shocked. Wait, you take 6 and you divide, you get 3/100ths. There's going to be, well, yeah. I was going to go for a different explanation, but I'll just leave it there. Because of how tiny small they are. Yeah. Okay, let's go ahead and do F. I want to throw in one that has a squared in it because I think you saw a squared in homework. I'll have to double check that, but Okay, so you've got an example under your belt. You kind of know what you're doing here. Log of 2x squared minus log of 5 equals 1. Where do you start? 2 logs being subtracted can be rewritten as 1 log where the insides are divided. So log of 2x squared minus log of 5 can be rewritten as log of 2x squared over 5 equals 1. Again, kind of looks ugly, but give it a chance. We have 1 log, so now we're going to do, what's my phrase? Left, right, middle. Again, invisible base of 10. So tell me what that left, right, middle is. 10 to the first, so left to the right equals the middle. What's middle? 2x squared over 5. Well, good news. 10 to the first is just 10. You might like this fraction work a little bit better. Think like last time. If it's 2x squared divided by 5, how do you get rid of the fraction? How do I get rid of the denominator? If it's dividing by 5, we're going to multiply by 5. If I multiply one side by 5, multiply the other side by 5. 5 times 10? 50. On the right, the whole point of multiplying by 5 is the 5 canceled, and I have 2x squared. How do I keep going here? If it's 2 times x squared, we want to divide by 2. Now what am I at? Okay, 25 equals x squared. I'm going to go ahead and reverse it and say x squared equals 25. Okay, digging those brains. If the x squared equals a number, we square root. What is the square root of x squared? X. What is the square root of 25? In an equation setting, when we take the square root, what should we always consider? Plus or minus 5. Now, pause for a moment. I didn't think about talking about this earlier, but we just got a negative answer. The inside of a log can never be negative. You remember that? So you need, here's what I'm saying. You need to check your answers. I'm not saying it doesn't work. I'm not saying it does work. You need to check. So if I go back up here and I put in for x, what's the first thing I do when I put a value in for x here? In this particular problem, we are squaring it. What happens when you square any number? It becomes a positive. So could I have a negative answer here? Yes. Now, if it just said log of 2x and we go to put in negative 5, that's a problem. The negative would not work then. Okay? So, not quite as much time as I had hoped to get you guys, but your homework that is due tomorrow is lesson 7.5 in Math Excel. You do have a few minutes, like 9. It's more than what it seems, really. No, 8 minutes, I guess, but you could get a little bit done.